So hi guys, Skelly is here with me. He's telling you to stay 6 feet apart and wear a mask, though I think it's a little late for him. Anyway, um, this part is for saturated and unsaturated fats for AP Bio. And I've got a few models I've built and everything, so hopefully this is really, really helpful. There we go. So important to remember that this only applies for fatty acids and when we're talking about triglycerides. So if you see, I know we talked about before that steroids count as fatty acids or count is in our lipids category, but this doesn't apply to that. And when we're talking about fatty acids, we're really only talking about we're talking about saturated and unsaturated. We're only talking about how the carbon atoms go together. Indirectly, that's talking about how many hydrogens are on the carbon atom, but that's really about it. Um, when you're talking about saturation and unsaturated, this is going to make a big difference about how the carbon chains, when you get a triglyceride or a phospholipid, how they're able to interact with each other and what kind of characteristics it gives them. It has overtones in our diet, and that's probably about how you guys have heard of them before, but it also has effects when we talk about cell membranes later in the year. Um, so you've probably heard about this stuff in everyday life. And so hopefully that gives you a little bit of a frame of reference so it's not as odd as some of the things that we've talked about in other places. So when we talk about saturated fatty acids, what we're saying is that in that long, sometimes it's short, but in that long carbon chain, all the carbons are bonded together with single bonds. So by extension, what's going on is that when you look at the amount of hydrogens attached to the carbon, it's got the maximum amount of hydrogens that it could possibly have. So if you're looking in the middle portion of the chain, each carbon is going to have two hydrogens and then carbon-carbon bonds, because every carbon always has four bonds. So carbon single bond going one way, carbon single bond going the other way, and then hydrogen-hydrogen. And only that last carbon on the chain is going to be a carbon single bond and then three hydrogens. A lot of animal fats are like this. So all the good things in life that you can think of, like butter, or if you're a barbecue person like me and you like brisket and bacon and sausage, all of those fats that tend to be not solids, but a little bit more solidified at room temperature, that's the kind of stuff that you're going to be thinking about. They're very stable. They store a lot of energy. A high-fat diet kind of makes sense. So I'm going to give you two examples of a saturated fatty acid on a couple slides here. So this is actually not butter because butter would be a triglyceride, but this is butyric acid. So it's a 4-carbon chain, and you look at it, you've got this COOH, your carboxyl group, but then you've got CH2, single bond, CH2, single bond, CH3, all carbon-carbon single bonds, and the maximum amount of CH bonds that you could get. Pretty simple. If you look at a longer one, and we got to go back. Here's stearic acid. And you're going to start seeing with some of these other ones, you're going to see line structures that we'll talk through. This is a really long one, and I didn't count up the carbons, but if you look at the chain, all carbon-carbon single bonds, and then the maximum amount of CH bonds that you could possibly get. So you're going to, if you also see the term again, hydrogenated, completely hydrogenated, it means the maximum amount of carbon-hydrogen bonds you could possibly get in that structure. And that's all it means. So don't make it any more difficult than you possibly could. So this is a saturated fatty acid, and a very long chain at that. So when we're talking about saturated fatty acids, we're not talking about how many carbon-carbon bonds you get or how many carbons you get in there. All we're talking about is carbon-carbon bonds. If they're all carbon-carbon single bonds, it's a saturated fatty acid.